Okay. So here lecture 8, the second part of audio signal processing, frequency based signal processors, right? Sorry, so this is related to that one here. So equalizers and filters. So in equalizers or filters, so what they mainly do is they play with they do some things. They change. They play with the frequency, right? So if you remember, right? So we talk about different aspects of audio or sound, right? If you take sound, so we have different aspects, right? So with the time, right? If we just graph a audio signal or sound signal, with the time, amplitude is changing. Amplitude. If we have high amplitude, so that means the loud, it is a loud sound. Low amplitude means it is low sound, right? So Audacity, so let me open the Audacity as well. So it will be needed. Okay, right. So usually, if you have used Audacity, so if you record something, if you record any sound, it will show you that. It will show you the time and the amplitude. So in if you record very loud sounds or loud noise, so then it will show like something like this, right? So in Audacity, right? So if you record something like low sound, right? So the amplitude would be closer to the middle line, something like this. It is amplitude, time amplitude. So that's the first aspect of sound, the time, how amplitude is changing with the time, right? So this is related to dynamics. Last time, like we talked about compressors and all. So in that case, we change this amplitude, right? Dynamics. And the other thing is frequency. Frequency cannot be seen. So even in Audacity, so we cannot see directly, we cannot see what is the frequency of this sound. Of course, frequency is changing. Frequency could be changing with the time, but frequency cannot be seen at this in this view, in this perspective, right? So in that case, I told you we need a different perspective. So this is called time domain signal, right? Instead of that, we need frequency domains. So time domain to frequency domain, we can. So again, we check intensity. We call it amplitude. This one is amplitude, but usually it is, the better word would be intensity. Intensity. So in frequency domain, you can time එකත් එක්ක අර මේ sound එකේ මේ කියන්නේ low high ඒව change වෙන විදිය තියෙන එකෙන් ඒ perspective එකෙන් අපි ගන්න ඕනේ frequency එක. frequency එකේ intensity වැඩි වෙන්නේ කොහොමද කියලා. වෙනස් වෙන්නේ කොහොමද? How frequency is doing in our sound. frequency කොහොමද මේකේ සෙල්ලම් දාන්නේ කියලා. හරි. So then so usually like in our audible range, so we can hear from 20 hertz to usually we say 20,000. It would be the maximum. 20 kilohertz. Right, 20 to 20,000, right? So that range, frequencies in that range. So how they are intensities, right? So usually some frequencies would be dominating, right? So I don't know, it depends on the sound, right? If we take one second of a sound, so we can create, it is frequency domain perspective. Yani තප්පරයක sound කැලක් මෙතනින් අපි ගත්ත කියලා සම්මත. ඒකත් එක අපිට convert කරන්න පුළුවන් මෙන්න මේ frequency domain එක. ඒතර ඒ තප්පරයේදී මොන frequencies ද වැඩිපුර තියෙන්නේ, මොන frequencies ද අඩුවෙන් තියෙන්නේ, අන්න ඒ perspective එක ගන්න එක තමයි මේ frequency domain. Actually, so usually, so one way of doing this is FFT, or we call Fourier transformation. FFT means fast Fourier transform, or Fourier transform. Fourier transform, it is a function, right? In most of the programming, for example, like in Python libraries, so they have FFT. So if you give our signal into that function, it will give the frequency domain as a result, right? How frequencies are changing, right? So if we want to deal with frequencies, so we have to do this first, right? So we have to change it from time domain to frequency domain. We have to do that. But actually, if you are working in, for example, in a DAW, you don't have to do that because our software does that for us. You don't have to worry about that, right? එතකොට ඒ කියන්නේ අපි මේ ෆ්‍රීකවන්සි එකත් එක්ක වැඩ කරද්දි මේ අපි මේක කන්වර්ට් කරගන්න එහෙම මොකුත් දඟලන්න ඕනේ නැහැ. ඒ වැඩ ඒ ඇතුලෙන් කරනවා. අපිට එච්චර බය වෙන්න දෙයක් නැහැ. අපි වෙනකොට දැනගන්න ඕනේ මෙතන මොකද්ද වෙන්නේ කියලා. ඒකයි මෙතන මේ කියන්නේ. Right? So what is the difference between frequency and pitch? Can anyone tell me? Actually remember? Frequency and pitch. And pitch. What is the difference? What are you? Manomi? Ramesha, frequency and pitch, what is the difference? Akala?
Actually, both are the same.
Yeah. Yeah, the frequency is like how many yeah, frequency describes a physical phenomenon. Krishan says frequency describes physical phenomena. Pitch describes a yeah, perception. In a sound wave, so frequency is there. Even we are not there to listen, frequency is there. Frequency කියලා කියන්නේ එන්න මෙහෙම කීයක් තියෙනවද කියලා. So how many waves are there? If this is considered as one circle, so how many circles are there? In one second. 1 second of time. එක තප්පරයකට කීපාරක් මේක මේ හෙලවෙනවා. That's the frequency. It is a physical phenomenon. So even we are not there, the frequency is there. But pitch is how we perceive, our perception. ඒ කියන්නේ frequency එක අපි අපේ කන අඳුර ගන්න විදිය තමයි pitch එක. But it is, so frequency and pitch are the same, right? So check this up, frequency and pitch, so what is the difference? Right, okay. So කියන්නේ දැන් උදාහරණයක් විදිහට ගත්තොත් එහෙම high pitch sing කරන්න පුළුවන්. high pitch sing කරන්න පුළුවන් කට්ටිය කියලා කියනවා. උදාහරණයක් විදිහට ගත්තොත් දැන් ලංකාවේ ඇන්ජලින් ගුණතිලකට high pitch sing කරන්න පුළුවන්. يعني high frequency එයාට sing කරන්න පුළුවන්. දැන් ලංකාවේ විදිහට ගත්තොත් ඊට පස්සේ low frequency sing කරන්න පුළුවන්. නිකන් අපි ගත්තොත් නිකන් අර මේ ගොඩක් ඔය බයිලා කියන කට්ටිය එහෙම ඉන්නවා මේ නිකන් බොහොම මේ නිකන් ගැඹුරු හඬ වල තියෙන කට්ටිය කියලා කියන්නේ. ඒ කට්ටියට low pitch sing කරන්න. හරි. මොරිස් බානි විජේසිංහ එයාට ගැඹුරු හඬක් තියෙන. එයාට මේ low pitch sing කරන්න. ඒතර low frequency එයාට sing කරන්න පුළුවන් කියලා කියනවා. If you take the world music, for example, Ariana Grande, so very young singer, Like she can sing high pitch. So actually it is called the whistle register, right? So අකලංක මෙනෝ, right? Like ඒකට අර කියන්නේ උඩ දැන් සාමාන්‍ය අපිට දැන් කියන්න පුළුවන් level තියෙනවනේ දැන් අර සිංහල සංගීත විදිහට කිව්වොත් මධ්‍ය සප්තකය, උච්ච සප්තකය එහෙම තියෙනවනේ. මන්ද සප්තකය එහෙම දැන් අර ස්වර 7ක් තියෙනවා මැද. ඊට පස්සේ ඊට කලින් තව ස්වර 7ක් තියෙනවා. අන්න එහෙම මේ තියෙනවනේ levels. එතකොට Ariana Grande ඊට පස්සේ තව කවුරු හරි මරාය කැරි. එයා දැන් අපි පොඩි කාලේ බොහොම ජනප්‍රිය සිංගර් කෙනෙක්. ඒ කට්ටියට කියන්න පුළුවන්. ඒ කියන්නේ දැන් අපි කියනවා වගේ ඒ වගේ ස්වර 7 ඒවා දැන් අපි සප්තකය කියලා කියන්නේ දැන් ඔක්ටේව් කියලා කියන්නේ. ඒතර ඔක්ටේව්ස් කීපයක් එහායින් ඒවා ඒ කට්ටියට සිං කරන්නේ. ඒ කියන්නේ අපි දැන් කීබෝඩ් එකේ දකුණු අත පැත්තේ වෙන්න තියෙන ස්වර කියන්න පුළුවන් ඒ කට්ටියට හයි පිච් කියන්න කට්ටියට. ඒතර ලෝ පිච් කියන්න පුළුවන් කට්ටියට මේ ඒ කට්ටිය මේ වම් අත පැත්තට වෙන්න වැඩිපුර කියන්න පුළුවන්. හරි. එතකොට දැන් සමහර කට්ටියගේ රේන්ජ් එක වැඩි. ඒ කට්ටියට වම් පැත්තේ ඉඳන් දකුණු අත පැත්තට යනකම් ලොකු රේන්ජ් එකක් ඒවා සිං කරන්න. හරි. ඒ වගේ දැන් ඔය කට්ටිය පොඩක් මතක් කරලා බලන්න ඔය කට්ටිය සිංගර්ස් ලගේ ඒ කට්ටියගේ රේන්ජ් එක කොයි වගේද? ඒ කට්ටියට හයි පිච් කියන්න පුළුවන්ද? ලෝ පිච් කියද්දි කොහොමද? ඒ වගේ. දැන් උදාහරණයක් විදියට මේ අර Queen කියලා බෑන්ඩ් එකක් තිබ්බේ. ඒකේ මේ සිංගර් ලීඩ් සිංගර් ෆ්‍රෙඩී එයාට පුළුවන් ලොකු රේන්ජ් එකක් සිංගර්. ඔය කට්ටිය බැලුවොත් එහෙම මේ Queen බෑන්ඩ් එකේ සින්දු වල මේ ලොකු රේන්ජ් එකක් තියෙනවා. හරි. ඒ කට්ටිය කියන්නේ දැන් අර Bohemian Rhapsody කියලා සින්දුවක් තියෙනවා කට්ටිය. අහලා ඇති ගොඩක් අය. මේ ඒක එහෙම මේ සෑහෙන ලොකු රේන්ජ් එකක් යනවා. ඊට පස්සේ අර We Are The Champions කියලා සින්දුවක් තියෙනවා. අනේ වගේ මේ ලොකු රේන්ජ් එකක යනවා. ඒතර ඒ කට්ටියට මේ රේන්ජ් එක ලොකු රේන්ජ් එකක කියන්නේ. හරි. ඒතර ඒක තමයි පිච් කියලා කියන්නේ. The pitch කිව්ව ගමන් මේකේ frequency එකත් අදාළයි. කියන්නේ high මේ ලොකු ඒ කියන්නේ අර ඒ කටියට ලොකු frequency එක කියන්න පුළුවන්. Right? Right. Okay. So pitch and frequency they are same. Pitch is when we are listening how our perception of the frequency. Right, okay. So the frequency, right? So now we are looking at frequencies. Let me, okay. Right. So any sound we listen, for example, the sound that you listen at the moment, my voice and other noises around here, right? So when you hear this sound, it is a combination of many frequencies, right? කියන්නේ මම දැන් මගේ මේ සද්දේ ඔකට රෙකෝඩ් කරලා ඒක චෙක් කරලා බලුවොත් ඒකේ හඬ ඒකේ frequencies හරි ඒකේ තප්පරයක් අරගෙන ඒකේ frequency domain එකට ඒක දාලා බලුවොත් එහෙම මේක frequency එකතුවක් තියෙනවා. So any sound is a combination of frequencies. Combination of frequencies. Some frequencies is having high intensity, some frequencies are low in intensity. Some frequencies are dominating, some are not so much. Some frequencies are not there. Then in some sounds, there are many frequencies. There are many frequencies. In some sounds, there are only few frequencies. Right? In some sounds, there are many frequencies like this. In some sounds, there will be only few frequencies. Few frequencies are there. Others are seen. Right? So anyhow, most of the sounds, almost all the sounds are combinations of frequencies. Combinations of frequencies. So there's a concept called white noise. White noise. White noise. So white noise means, so white noise, one example is if you go to a waterfall, right? If you go to a waterfall, so you listen to a sound, right? Waterfall sound. It is white noise. Why it is white noise? Because the reason is it has almost all the frequencies. So if we take the frequency domain, if you record the waterfall sound, so you will get something like this. So all the frequencies would be there. The reason is when like it is the sound of hitting water, right? Right on like water molecules on other water molecules and some other surfaces, right? Makari batu pitakata වතුර වැටෙද්දී ඒ වතුර වැටෙන්නේ අර එක එක විදිහට. හරි ඒතර මේක මේ එක එක විදිහට දැන් මේ වතු පිට එක එක විදිහට වතුර වැටෙනවා. එතකොට එක එක විදිය frequencies එනවා. එකෙන් මේ වතු වෙනවා. ඒක හින්දා මේ සාමාන්‍ය අපි කියනවා මේ white noise එකේ all the frequencies ඔක්කොම frequencies තියෙනවා. නැති frequencies නැහැ. ඒතර white noise එක frequency domain එකේදී මෙන්න මේ විදිහට තමයි පෙන්නන්නේ. කොහොමද තියෙන්නේ? කොහොම frequencies. So white noise can be used to mask other sounds, right? So if you want to mask other sounds, you can use white noise. You can then සමහරලාට ඔය මේ කියන්නේ ගෙදරට හොරෙන් කාට හරි කෝල් එකක් ගන්න ඕන වුණාම සමහර කට්ටිය කරනවා. දැන් මම දන්නේ ඔය කට්ටිය කරනවද කියලා. මේ කියන්නේ මේ ටැප් එකක් ගාවට ගිහලා ටැප් එක ඇරලා කතා කරනවා. බාත්රූම් එකට ගිහිල්ලා මේ ෂවර් එක ඇරලා කතා කරනවා. ඒතර අර මේ ෂවර් එකේ වතුර වැටෙද්දී මේ වෝටර්ෆෝල් එක ලෙවල් එකට නැතත් මේ අර මේ අපිට මේ සෑහෙන දුරකට white noise එකක් ගන්න. white noise එකක් ගන්න පුළුවන්. එතකොට අපි මේ දැන් මෙහෙම white noise එකක් තියෙන තැනක අනිත් එකක් ඇහෙන ගතිය අඩුයි. I don't know whether you have watched the movie Quiet Place. Quiet Place නේද? ඒ මූවි එකක් තියෙනවනේ Quiet Place කියලා මේ ඉමිලි බ්ලන්ට් එහෙම ඉන්න. බලලා තියෙනවද කවුරු හරි? Quiet Place. So Quiet Place in that movie, so so they are in a world that they cannot make sounds because there are some creatures or maybe aliens, I don't remember exactly, like they are sensitive to sound, right? if you make any sound, so they'll come and kill you. Right? So they, the people live there, so they cannot make any sound. Right? So then, if they want to make a sound, right, like if they want to scream, so they go to a waterfall, and then they go inside that waterfall, and then they scream. So then, with that white noise, their screaming would be masked. කියන්නේ අර මොනවාරි කෑ ගහන්න ඕන නම් මේ කට්ටිය දියැල්ල ගාවට ඉහළ දියැල්ල ඇතුළට ගිහිල්ලා කෑ ගහනවා. එතකොට ඒක ඇහෙන්නේ නැහැ එළියට අර ඒ සතාට එන්න බෑ. So white noise is like all the frequencies are there, right? So then, like, so usually, so I wanted to tell you, like, some sounds, they have all the frequencies that can have. In some sounds, there are few frequencies. Some sounds, there are many frequencies combined. Anyways, any sound is a combination of frequencies. Any sound is a combination of frequencies. Right, so what we do here, right, what we do here is, we have something called filters. Filters. Right, filters, these are actually, we can call them frequency filters. We don't use frequency, but in audio production, filters means, so we have a sound, right? So we have a sound. So we have a sound. So we have a lot of frequencies here, right? So if I F1, F2, F3, likewise also combined, frequencies are combined. If you send these frequencies through a filter, so we can filter frequencies, some frequencies. The output signal may have F1, F2, but not F3. So likewise, we can filter some frequencies, right? So filtering is that, right? Filtering is that. So in EQ, equalization, right? So we, in sound processing, we have a step called EQ. In that case, what we do is we filter some frequencies. We filter some frequencies. Which frequencies would be the question, and based on that, we have different filters. Right? So I cannot open Audacity. So there's a problem with my computer. It may need a restart. So if I cannot show you now, right? So I will show you. I will record that in the video that I told you, like maybe day after tomorrow. So I'll share a video with some practical aspects of these concepts, right? But if you use Audacity, right? If you go to effects, so if you have just import any sound, any audio to Audacity, and then if you select some part of the sound of that audio file, if you select some part of that audio sequence, and then go to effects. Yeah, as I remember, effects. So they are, so you have EQ, right? I don't remember exactly, right? If you go to this effect menu, and then you will find something, EQ something. I don't remember exact name. Then you will get something like this, right? So there would be frequencies here from maybe up to 20,000 or something, from 0 to 20,000. And then there's a line. Then you can select some parts, right? For example, if I select 80 hertz, if I select that, and then I can change, right? I can change. Right? I can change it like this. And then you can select some other one, right? Like, for example, like 1000 hertz. If you select, and then you can change it, something like that. So likewise, you can change the frequencies, right? You can boost, you can drag and drop some parts, like for example, this part you can make it like this, like this. Yeah.
I think equalizer start from 20 hertz.
Oh yeah, it could be, yes, 20, because that's the sound that we can listen, right? Yes. But anyway, like I mean, so the idea here is like we can change. I don't remember exactly, but it is 20,000. But maybe in some equalizers, there would be more than that. I'm not sure exactly, but so usually the range that we can hear, our audible range. Sounds would be there. Right, so we can change. So what we can do is we can boost some sounds, and we can reduce some sounds, so some frequencies, right? Some range of frequencies, right? So based on that, so we have different filters, different type of filters. We have different types of filters. So here, yes. So here you can see starting from 20 hertz. 20 hertz. As, so Kalaki, you are correct. 20 hertz up to 20 kilohertz, 20,000 hertz. Right. So we can change. So equalizer, EQ are filters. I mean, filter and equalizer, the difference. It is, you don't have to worry about the difference of equalizer, whether equalizer is a filter or something, you don't have to worry. But in equalizer, we do filter. Basically, we do filter. selectively boost or attenuate. Attenuate means reduce frequency regions. Some frequency regions can be make up, and some frequency range can make down, right? So in that case, like here, one thing we cannot do, that is like in the source file, we cannot add new frequencies to the source file. අලුතෙන් frequencies add කරන්න බෑ. තියෙන ඒවා වෙනස් කරන්න විතරයි පුළුවන්. තියෙන frequencies වල වෙනස් කරන්න පුළුවන්. ඒ කියන්නේ දැන් අපි කියනවනේ මෙන්න මේ range එකේ අපි හිතමු 20ට sorry hertz 80ට වඩා අඩු ඒවා අයින් කරන්න කියලා කිව්වොත් 80ට වඩා අඩු ඒවා ඒ source එකේ නැත්තම් අයින් කරන්නේ නැහැ. තියෙනවා නම් අයින් කරන්න. Mixing out of phase signals can cause filtering. Right. So these are some parameters that we can use in a filter. Right. එතකොට මෙන්න මෙහෙමයි කරන්න අපි මෙතන sorry right so we can change the intensity of some frequency ranges, and we can like as I told here, boost to attenuate. සද්ද වැඩි කරන්න පුළුවන් සමහර frequency වලින්, සමහර frequency range වල සද්ද අඩු කරන්න. So that's what we do. Right, so here then the parameters are these, right? So the mainly gain, right? So we can check how much we boost or how much we attenuate. කොච්චරකින් වැඩි කරනවද, decibel කීයකින් වැඩි කරනවද, decibel කීයකින් අඩු කරනවද, ඒක තමයි gain. 0 decibel is no change, right? Otherwise, maybe positive or negative, right? Gain would be positive or negative. If it is 0, we don't change that, right? Right. So at the beginning, right? At the beginning, it would be something like this, 0, right? Then some parts can be boosted, some parts can be attenuated, right? For example, I boost between like 80 to 1000. I boost that, right? So I can attenuate, for example, under 20, I can attenuate. Right? So likewise, we boost to attenuate. So this is the 0 level. If it is 0 level, like if it is 0 means we don't change that, right? The original signal would be not changed. Right? So maybe equalizer එකේ ඔක්කොම 0 කියලා මෙන්න මේ ඔක්කොම range එකම 0 කියලා තිබ්බොත් එහෙම ඒ filter ඒ කියන්නේ මොකුත් filter කරන්නේ නැහැ. ෆිල්ටර් එකේ මොකුත් කරන්නේ නැහැ, චේන්ජ් කරන්නේ නැහැ. අර මේ ඔරිජිනල් සිග්නල් එකේ ඒ විදිහටම output වෙනවා. Right? So that's the gain. Then in a different EQs may have different names, right? Then this one roll off or slope. Change in gain or frequency measured in decibel to octave. So octave means as I told you, like ස්වර 7ක් ප්‍රධාන ස්වර 7කින් හැදිච්ච එකක්. ඒතර ඒ ස්වර 7කට කොච්චර චේන්ජ් වෙනවද? ඔක්ටේව් එකක් කියලා කියන්නේ සාමාන්‍යයෙන් දැන් ඔක්ටේව් එකක දැන් සාමාන්‍යයෙන් මෙතන ෆ්‍රීකවන්සි එකක් තියෙනවා කියලා නම් එක නෝට් එකක ඊළඟ ඔක්ටේව් එක පටන් ගනිද්දි මේක ඩබල් වෙනවා. right? කියන්නේ දැන් මෙතන 440යි නම් තිබ්බේ 880 ඊළඟ ඔක්ටේව් එකට. මෙන්න මේ ෆ්‍රීකවන්සි රේන්ජ් ඔක්ටේව් එකක් කියලා කියන්නේ. මේක ඩබල් වෙන ෆ්‍රීකවන්සි. මේ ෆ්‍රීකවන්සි රේන්ජ් මේ ඔක්ටේව් එකකට how many decibels are changed to an octave. Right? It is like here it is talking about the slope. So what is slope actually? Slope is right, like we can change, right? So we can change, suppose from here to here. So I want to change it. So then how it is changing, right? How it is changing. So that's the right. How it is changing. I can change it rapidly. I can change it not so rapidly, right? This slope you can make මෙතන ඉඳන් මෙතෙන්ට අපි වෙනස් කරනවානේ මොකක් හරි අන්නේ චේන්ජ් කරන ඒ ශීඝ්‍රතාවය. ඒක තමයි ස්ලෝප් එක කියලා. ඒක චේන්ජ් කරන්න පුළුවන්. මෙහෙම චේන්ජ් කරොත් ඔන්න මෙන්න මේ විදිහට චේන්ජ්. And ඒක තමයි මේ ස්ලෝප් කියලා කියන්නේ. ස්ලෝප්. A change in gain over frequency measure. Right. So then bands and bandwidth measured in octaves or Q. So that means what is the range that we are changing? What is the frequency range that we are changing? In a previous example, I told you like 80 to 1000, right? So likewise, the frequency range. And then center and cutoff frequency. So sometimes it is we consider the center frequency or cutoff frequency. A frequency එකෙන් එහාට අපි අයින් කරලා දානවා. ඒ මොකක් හරි අන්නේ frequency. So these are the parameters in a filter. So based on these parameters, we can identify different types of filter types. Right? So low high pass. So it is like this. It is like this. Okay, so let's talk about the main two types: low pass and high pass. So low pass is also called high cut filter, low pass filter or high cut filter. High pass filter is also called low cut filter. So the low pass means low frequencies can pass but high frequencies are cut off. Right. So in our frequency range, right? So we can decide one place, right? So one cutoff frequency, one, for example, like 80, right? 80ට වඩා අඩු frequencies වලට යන්න පුළුවන්. 80 අපි ගන්න නැතුයි අපි ගමු 1000 වගේ. Low frequencies can pass. And low frequencies තියෙනවා high frequencies. මෙතනින් එහා ඒවා අපි අයින් කරනවා. Low pass, low frequencies can pass. That's why we call low pass or high cut. High frequencies are cut off. High frequencies are cut off. So they are removed. Can 1000ට වඩා වැඩි ඒවා අයින් කරනවා. ඒක ක්‍රමානුකූලව අයින් කරන්න. This is called low pass. So the opposite of that would be high pass. Low frequencies are cut off. Right? Suppose low frequencies are cut off. Suppose under 80, so high frequencies are allowed. High frequencies can pass. High pass speed. High frequencies can pass. High pass or low cut. Low frequencies are cut off. These are cut off. The original signal, low frequencies are there. If we cut off those low frequencies, then in the result signal, low frequencies are not anymore. It's called low frequency. So low cut. Right. So this is low pass. Low frequencies can pass. High frequencies are cut off. High pass. High frequencies can pass. Low frequencies are cut off. So similarly, so we have another band pass. One range can pass. So we can decide, we can define which range, but one range can pass. Other frequencies are low frequencies than that range and high frequencies than that range are cut off. Only band can pass, band pass filters. Right? And the opposite of that, one band is cut off. One band is cut off. High frequencies than that band and low frequencies and high frequencies than that band or that range can pass. So this is called band stop. So we can define different names, but the idea is that. So and apart from that, so we have something called peak or notch filters. Peak or notch filters. That means so notch filters. So some frequency, given frequencies can pass. Some frequencies can pass. Right? Or some frequencies would be boosted, or some frequencies would be cut off, right? Like one particular frequency would be cut off. Only this frequency, like, oh, it's a small range. It's a band pass, band stop filter, but still the band is very narrow. Band is very narrow. Band pass. And then, so this is called notch. If you have a set of filters, like set of frequencies, right? Like we have a set of frequencies, like we cut off this frequency and this frequency and this frequency. Set of frequencies cut off. So these are called, this is a combination of notch filters. This is called, there's a special name, home filter. Home filter. So likewise, we have different types of filters, right? So you can cut off different frequencies. It could be a narrow band. It could be a very high range. Doesn't matter. So you can give different names to those. So anyhow, like, so the idea is, so we are filtering frequencies. And then, so we have filters, and there's another concept called shelves, low, high shelves, right? So if we get this one, high pass, it is understandable, right? So you can identify low pass, that's also right. Low shelf or high shelf, right? So in this case, so in high pass, low frequencies are cut off totally. But in these shelves, they are not cut off totally, right? So this is cut off or filter, right? However, in shelves, we don't cut off. We don't cut off. So, we don't cut off. What we do is, it would be 0, and then like this. Not cut off, not changing anything there. Not changing anything, but boosted other terms. Right? So that's the idea of high shelf and low shelf. So, so I will show you actually, like in, for example, like in Cakewalk, if you are doing EQ, so you can select, it is whether it is peak, high shelf, low shelf, high pass or low pass. So these can be selected, which filter you want to add there. Right, okay. So these are, so low, high pass, high, low cut, right? Removing high frequency noise or bus. Removing low frequency stage noise, machine noise, hum. Right? So in this case, like if you remove low frequencies, so most probably low frequency like machine noise or hum, stage noise, those things would be removed. And ගොඩක් වෙලාවට දැන් අර මේ පිට නිකන් අඩු සංඛ්‍යාත තියෙන මේ අඩු ෆ්‍රීකවන්සි තියෙන සවුන්ඩ්ස් ගොඩක් වෙලාවට අපිට වැඩක් නැහැ. ගොඩක් වෙලාවට හැම වෙලාවෙම නෙවෙයි සමහර වෙලාවෙදී මේක වෙනස් වෙන්න පුළුවන්. හැබැයි මේ ගොඩක් මේවලදී අපිට වැදගත් මේ ෆ්‍රීකවන්සිස් ටික තියෙන්නේ ගොඩක් වෙලාවට මිඩල් රේන්ජ් එකේ වෙන්න. අඩු ෆ්‍රීකවන්සි තියෙන ඒවා ටික ඔක්කොම අයින් කරොත් එතකොට සමහරලාට අඩු ෆ්‍රීකවන්සි එකෙන් තියෙන නොයිස් එහෙම අයින් වෙලා යනවා. ඒ වගේම තමයි හයි ෆ්‍රීකවන්සි සමහරලාට දැන් අපි තියෙන්න පුළුවන් මේ හයි ෆ්‍රීකවන්සි නොයිසස් තියෙන. ඒවා අයින් වෙලා යනවා උඩ ඒවා එක. Right? And also we can isolate one frequency region. Right? To remove leakage. But the thing is, so you have to be careful. So you can do this, but there are harmonics, right? So if you have one sound, like one tone, there could be harmonics of that tone. ගැන අපි දැන් සා කියලා නැත්නම් මිඩල් C එක ගහනවා කීබෝඩ් එකේ මිඩල් C එක ගහද්දී මිඩල් C එකට අදාළ ෆ්‍රීකවන්සි එක විතරක් නෙවෙයි ඒකේ හාමොනික්ස් ඒකේ ඩබල් එක ඒකේ තුන් ගුණය යන්නේ එහෙම ඒව මේකේ තියෙනවා මේ සවුන්ඩ් එකේ හාමොනික්ස් තියෙනවා. ඒතර හාමොනික්ස් අයින් වුණොත් මේ සවුන්ඩ් එකේ විදිය වෙනස් වෙනවා. So be careful to avoid removing essential harmonics. Some are essential. If you remove that, the sound would be not natural. Right? අමුතු හඬක් එන්න පුළුවන්. Right? So low high shelves, all frequencies above and below a certain point are boosted or attenuated by the same amount. Right? So මේ මෙතනදී කරන්නේ එන්න මේ වගේ වැඩක්. High boost, high cut, low boost, low cut. Shelf. Right. Parametric equalizer. Boost or attenuate a range of frequencies centered around a certain point. Right? So that's what we do in parametric equalizer. Right? So these are the names for that. Right? So Bell EQ, a notch filter, peaking filter. So the different names are there. So these are the parameters: central frequency, bandwidth, and gain. So මේ frequency වල මැද frequency එකක් ගන්නවා ඒකල මේ රේන්ජ් එකක් ගන්නවා ඒක කොච්චර වැඩි කරනවා කියලා. ඒ ටික තමයි මේ parameters. Some parametric filters may not allow some or all three parameters to be changed. Right? මේ තුනම change කරන්න සමහර වෙලාවට දෙන්නේ නැහැ කියලා කියන සමහර වෙලාවට. Those are called semi parametric. Parametric equalizer, extremely narrow bandwidth boost will result in pitched overload. Favor boosting with broad bandwidth to shape regions of harmonics. So narrow bandwidth cuts can be used to remove noise, feedback, or other undesirable items. So mainly the idea here is to remove undesirable, unnecessary parts of our sound signal. Favor broad bandwidth parametric for low frequency boost or a low shell boost. So there are equalizers like this, right? So one parameter filters. Distributors across frequency range in equal octave segments, right? So මේකේ මේ equalizer එකෙන් යද්දි අපිට change කරන්න පුළුවන් මේකේ කොයි වගේද මේ එන්නේ කියලා. හරි. ඒතර ඒක මේ octave එකෙන් octave එකට ඒක sound එක දාගන්න. right? දැන් ඔය කට්ටිය මේ ගෙදර සාමාන්‍යයෙන් තියෙන බොහොම මේ primitive sound system එකක් තියෙනවා බොහොම primitive EQ එකක්. ඒ කියන්නේ අර bass එක කියලා කියන්නේ bass treble කියලා කියන්නේ. ඒතර bass එක කියලා කියන්නේ අපි වැඩි කරනවා මේ low frequency එක වැඩි කරනවා. treble කියලා කියන්නේ ඒකේ අනිත් පැත්ත. high frequency එක වැඩි කරනවා. ඒතර bass ඔන්න ඕකෙන් කරන්නේ මේ EQ එකක්ම තමයි. right? So these EQs are used in live sound engineering mainly. Right, so basically EQ. So at this point I cannot show you the examples how to do EQ in maybe in Audacity or Cakewalk, but I will record you that and I will upload that later, right? So that's all. I mean, it's basically filtering is what we do in EQ, right? We play with the frequencies, frequency ranges, selected set of frequencies, right? So then time-based signal processors. So then in previous case, we play with frequency, but in this case, we play with the time of signal. So there are many time-based processors, but mainly we consider few, like the reverb or revibration. We call revibration or reverb. In music production, or sound production, we call it reverb. And delays, right? So echo is one example, right? Then so we have flankers and chorus and then pacing and many other several time-based processors. So I'm not going to talk about all, but mainly, so I'll just introduce what is reverb and echo. But what you can do is, so those effects are there, right? Like even in any DAW, so you can use those effects, right? A reverb, echo, right? So those are there. So they mainly if I talk about reverb, so reverb, revibration, right? So revibration is very natural in any sound. Like when I am listening to what that I'm talking here, right? So I hear revibration. So revibration is the reason for revibration is sound is, so maybe I have some, yeah, so here like acoustic revibration, it is very natural, right? Like if you are making sound in your room, so it has some echoing, but not echoing actually, right? Like කියන්නේ අර නිකන් හඬ නිකන් අර රෝම්කාර දෙනවා වගේ පොඩි ගතියක් එන්නේ කාමරය ඇතුලේ. දැන් ඒ කියන්නේ දැන් උදාහරණයක් විදිහට මේ ලොකු රූම් එකක හිටියොත් එහෙනම් එකෝ එක ඇහෙනවා. ලොකු රූම් එකක එකෝ එක ඇහෙනවා. So you can hear the echo in a big room. But if you are in a small space, you cannot hear the echo clearly, but the sound has some characteristic. It is called revibration. When we hear sound, we hear a mix of direct sound. And then if you have any surfaces around the floor and then the walls, we hear the reflections of our sound from those surfaces. කියන්නේ දැන් echo එකක් අපිට මේ clear echo එකක් ඇහුනේ නැතත් ඕනම sound එකක් එහෙම vibrate වෙනවා. ඒ කියන්නේ මේ vibrate වෙනවා. Individual reflections, we call them early reflection from nearby surfaces. Other reflections, so closely spaced and overlapping that our brain can't perceive them as separate. So here, the difference between echo and revibration is we cannot clearly hear the echo. We cannot separate those echoes. But in the difference in the echo, our brain can identify them. This is the first step. So if you shout in a big open area, like in a mountain, right? Like on a mountain, like if you shout, so then after considerable seconds, you can hear an echo, right? So that's the difference. Huh? So here, so you can hear them with the time. But in revibration, you cannot distinguish those echoes. Those are overlapped like this. So that's the difference between echo and reverb. So you can add these effects to your sound to make it more natural and more rich sound. So you can add that, right? Like reverb. So revibration, reverb is, there's a device actually, right, that you can use, and so especially like in guitars, and many other instruments. So you can add that reverb effect, right? So for example, so that's the birth of a new music genre, which is called surf music. Surf music. I don't know whether you have heard that around like 60s and 70s. Surf music is very popular in Western countries. Even in Sri Lanka, it was somewhat popular. Surf. They use a lot of reverb, right? So if you listen to the bands like, for example, yeah, so Deep Dale. So check this name. Like if you listen to their music, you will understand. Like they have like that reverb effect a lot, right? Can වැඩිපුර reverb පාවිච්චි කරනවා මේ surf music වල. detail කියන්නේ කෙනෙක් ඊට පස්සේ who else? So I'll give you some names later on, right? So you can check their music, so you will hear that reverb. Right. So here, time-based process. So there are common attributes, right? All employ delays. So there are some delays would be added. All are often processed in parallel, right? With auxiliary track or with mixed control. Right? All are often best used in stereo rather than mono. Right? All are easily overused. You can add echoes unnecessarily. Right? For example, a reverb is overused in surf music. So that's their one characteristic of surf music. Reverb එක වැඩිපුර පාවිච්චි. They can overuse, but don't do that, right? Use they only if necessary, right? Right. So reverb is right like direct sound and then reflections of other sounds, right? So this is the sound source. This is the listener. So you can see like it is a combination of a lot of reflections, direct sound plus reflections. So that's the reverb. Most of the natural sounds are reverb sounds. If you remove reverb from your sound totally, so then it would be unnatural, right? You need reverb to a certain extent. If you overuse that, that would be again unnatural, right? Right, okay. So usually we use reverb to provide that naturalness of sound. So recreating an acoustic space. So So if you use reverb properly, then you can provide that acoustic space. The idea about a space of that sound is generated. A sound එක generate කරපු ගමන් ඒ sound එකත් එක්ක පොඩි space එකක idea එකක් දෙන්න පුළුවන් ඒ sound එක. And it can be used as a special effect. Right? Reverb process. Right, so these are some parameters. So I will stop at this point. I will stop at this point. Then so tomorrow and day after tomorrow, so I will record another 2 sessions, right? Tomorrow session, so that would be the final session, and then day after tomorrow, so I will record session with some practical aspects of these things, right? Right, so so these are the parameters. So time domain graph. So in the time domain graph, decay. So decay is duration of revibration, time of tail to fall. Right. Right. So this is the time. In this case, it is the fall is 60 dB. It takes this time duration to go from here to there. Right. Then size. It is another parameter used here. And then pre-delay. So it is like so this is the direct sound. So this is where the direct sound is generated, and then after some time we add the reverb. Right? Reverb would be started here. Right? So before that, between the starting point and the original sound, it is called pre-delay. So usually a small gap would be necessary from the original sound and the starting point of the reverb. Right, it will be 30 milliseconds or so. Right. And then so we have early reflections, diffusion, wet dry mix. So those parameters would be there. Several parameters are there. Right. So here we talked about mainly reverb, but echo again we can add echo. Echo effect, right? So again, so they have different set of parameters. So apart from that, right? Apart from that, so we have some other sound effects, like for example, auto-tune. Auto-tune is used, actually overused in most of the modern pop music, right? If you listen to the music of like BTS, and then Justin Bieber. So who else? Like a lot of modern musicians, so they use auto-tune. Like their natural pitch would be changed, and then pitch bend. Pitch bend is another sound effect, right? The pitch is changed around the original pitch. Pitch එක එහාට මෙහාට කරන එක original. ඊපස්සේ මේ auto tune පාවිච්චි කරනවා මම හිතන්නේ දැන් ඉන්දියාවේ පාවිච්චි කරන ගොඩක්. ඉන්දියාවේ මේ අලුත් musiciansලා පාවිච්චි කරන auto tune. Not necessary sometimes, but use. Like the first people who used the auto tune in Sri Lanka is, I think, as I remember, BNS, Bhati and Santosh. They used auto-tune in their first album. Oh, first or second album, yeah, maybe second album. So they use auto-tune. So that's my, according to my memories, that's the first time I heard that in Sri Lanka. But now auto-tune is used a lot, right? Pitch bend, pacing, and flanging. So these are some other concepts. So like other effects that which are available, right? So I will share some videos that you can see how these sound effects work, right? And then vibrato. So sometimes also that effect is used in surf music. I told you, like surf music, like reverb and vibrato. So those are the main technical things in surf music, right? Like it is not sound effect, chorus, and so these are some sound effects. I'm not going to explain them in detail. My main concern here is reverb, right? And in practical, let's see how reverb and echo can be added and how they change the sound for the audio, right? Right, so that's all I'm going to do today, and then tomorrow at 5, the same time. So I will do a session, but I'm not forcing you to join that session. So I will record that sound even without anyone. So I will record that and I will upload. It would be a very small session, right? So and then a practical session. So overall, the main practicals that I haven't showed you anything, right? Right, okay. So that's all. So any questions? Actually, I wanted to make today's session maximum 1.5, but I was explaining the examination and other things as well, so it took time. Right, okay. So if you have anything regarding the examination and other things, so just let me know. Let me know, send me a message, or you can message directly to me, or you can message in the group. Right, so that's all, and see you tomorrow. You don't have to be there, but so I will record a session for you. Right, okay. Thank you and good luck with the preparations for the exam.